The German High Command has devised a method of package delivery. They will use dirigibles to drag packages to their destination. The lighter-than aircraft pulls on the cable with a force of 5,000 newtons. It fights a frictional force as it slides a package along the ground with a constant speed. Ooh, constant speed. That's a pretty big deal. If the kinetic coefficient of friction is 0.555 between the ground and the crate, what is the mass of the crate? All right, I'm going to go ahead and make myself a little list here. I have that is the highlighter. The force of tension because of the dirigible is 5,000 newtons. The angle there is 25 degrees. How do I know that? Well, I looked at the picture. It's not actually said in the problem, but it is given in the picture. So I'm just going to throw that information there. I'm also given that it's moving at a constant speed, and we're also, because there's friction between the ground and the box, we're going to assume it's not popping up off the ground. If it were popping up off the ground, there would no longer be any friction. So let's say that the sum of the forces in both directions are going to be 0 due to the fact that it's moving at a constant speed and it's not popping up off the ground. We have the kinetic friction coefficient of 0.555, and we're looking for the mass. All right. First step, draw my free body diagram. Ft is equal to 5,000 newtons. And the angle here is 25 degrees. Okay, then I have the force of gravity acting down. I'm going to draw that a little larger. And then we have the force of friction. Oh, hold on. We still have a normal force because it's still pushed against the ground, but it will be a little smaller than normal. It will not be equal to Fg. And I'll talk about why in a second. Then we have the force of friction going back. All right, so the next step after I draw my free body diagram is break up any of my anything that's at an angle. So right now I have Ft is at an angle. I'm going to draw this as Ftx and Fty. So just talking about how we draw our vectors, Fg, the magnitude of Fg should be about equal to Fn plus Fty when we make our drawings. Now, they will be exactly equal to Fn plus Fty when we do our calculations, but you should also be able to see it within the picture. Since it's moving at constant speed, Fk and Ftx should be about the same size as well. And I did my best to make that true. All right. Some of the forces in the y direction, we have two forces going up, not just Fn minus Fg equals 0. This time it's Fn plus Fty minus Fg is equal to 0. Then we have the sum of the forces in the x direction. Forces right minus forces left, Ftx minus Fk, also equal to 0. Now, if I take a look at these, I think, what's the question? And then I remember the question is, what is the mass? So these equations usually equal ma. But they don't today. They equal 0. So where's the only place there could possibly be an m? Try to think. Okay, here's your answer. It would be in Fg. Fg is mg. So this is where our m lives. So we're going to go ahead and try to just solve for the red equation, the Fy equation, and we're going to see if we get anywhere. So we start out with Fn plus Fty minus Fg. And instead of Fg, I'm going to put an mg there, so I have it. And I'm just going to add by mg on both sides. So I have Fn plus Fty is equal to mg. I'm going to divide both sides by g. And I get that m is equal to Fn, plus FTY divided by G. Now, luckily for me, I know what G is. G is 9.81, but that's where I stopped knowing things. I do not know what FTY is, and I do not know what FN is. So I'm going to see if I can go find those from other equations. Sorry, buddy.
I want to do something.
You can sit by me and listen if you want. Okay. So, to find Fn, I am going to think about what other equation has Fn in it. And when I think about what other equation has Fn in it, the friction equation comes to mind. I have that the force of friction is equal to mu k times Fn.
Can you do red?
In a minute. So here I have mu k, right? Mu k is given as 0.555, but I don't know Fk, so I can't even find it this way. But
I know how to draw a K.
Okay.
I can do it for you.
No, thank you, honey. So if Fn is equal to Fk divided by mu k. And I can
do a big K.
I can solve for Fk using this equation. So I have Ftx is equal to Fk. So if I can find Ftx, I will have Fk. And let's take a look. Can I find Ftx? Well, I have that the angle is 25, and I have the hypotenuse of this triangle is 5,000. So yeah, I have Ftx as my opposite side. So Fk, since it's equal to Ftx, will equal the hypotenuse, Ft, times cosine of theta. Ft is 5,000 newtons times cosine of 25 degrees. I'm just going to go to my calculator. And
I think that's 27.
5,000
hair height.
cosine of 25 degrees. And I get 4,031.538935. So I'm going to go ahead and just keep 4531.5. And I have here, now I have my Fk. Because I have Fk, now I can find Fn. Whew, this is a lot of work. So I'm going to go ahead and find Fn. Fn is 4531.5 newtons. Oops. Newtons. Divided by, I'm just going to slide up here, 0.555. And I get, so I'm going to, I know I didn't keep all of the digits, but my calculator did. So I'm just going to take my answer, answer, and I'm going to divide my answer by 0.555. And that equals 8164.935.
Can you do red now?
And again, it's still newtons. So now I have Fn, but I need to go find Fty.
Red.
Fty is the adjacent side of the same triangle. Fty is equal to Ft sine of theta. So I have 5,000 newtons sine of 25 degrees.
Mommy, can I do? Why do you keep going to these things?
It's a calculator, buddy.
It's a calculator.
It calculates different numbers and adding and subtracting. So if I put 2 plus 2 in here, what would I get?
4.
So let's try it. 2 plus 2. And what does that say?
4.
See? So it just does it for you. So I got 2113.09. I'm going to go ahead and just take that much of it. So
Let's see what 4 plus 4 is.
I forgot what it was. 2113.09.
4. 4 plus 4 would be.
Okay. So I have 2113.09 newtons. Okay, and now I'm ready to go ahead and calculate my final mass, finally. So I have Fn is 8164.935 newtons plus...
That's not a plus sign.
Yes, it is. 2113.09. And I'm going to put that in parentheses. I'm going to do white. Oh, hey, buddy. And I'm going to divide this. Oh, gosh, sorry.
What?
There we go. Divide that by 9.81 meters per second squared. Oh, I forgot my unit here. You gotta get off me. Okay. So now that I have this, plug in my calculator. I'm going to kind of cheat using the we already have here. So I have 8164.935 plus 2,113.0913. I'm going to hit enter here, and then I'm going to take that answer and divide it by 9.81. 9.81. And I get 1047.7. And it's newtons divided by meters per second. So I have newtons divided by meters per second, 1 squared, right? 1 newton is kilogram. Meter per second squared divided by meters per second squared, I get kilograms. But this is not 3 sig figs, so my final answer that I will write is 1050 kilograms. Boom. All right, thank you for watching. Say goodbye.